I'd like to introduce to you another fantastic formula, Ohm's law. When you've made yourself an electronic circuit and you want a precise way to keep track of the current in it, there is no better way. Please try not to confuse this with Ohm's law. Ohm's law says that the voltage across a circuit is equal to the current flowing through it multiplied by the circuit's resistance. We write the formula as V equals IR. Recall that voltage is measured in volts, current in amps, and resistance, by no coincidence, is in ohms. To demonstrate how this formula works, let's take a typical battery like this one and connect its terminals to the ends of a pencil. Pencil lead is graphite, which conducts electricity. We have made a circuit that uses graphite to carry a current. Now to put some numbers on it. The battery has 6 volts on its label, which means it sends out a current with 6 joules of energy per coulomb of charge. The graphite in the pencil has a resistance of 12 ohms. How do we calculate the current going through the pencil? We use Ohm's law, of course. V equals IR. Since we already know the voltage and want to find a current, we need to rearrange this. Divide both sides by R to get I equals V divided by R. Now, substitute in the numbers we know. Voltage is 6 and resistance is 12, so I equals 6 over 12. And what does that come to? 6 divided by 12 is the same as a half, so the current is 0.5 amps. Always remember to include those units, and round your answers if you're asked to. Ohm's law is a powerful way to predict certain properties of a circuit, but it has limitations. All the resistors you will come across follow the law, but some other components, like diodes, do not. A diode is designed to only allow currents to flow through it in one possible direction. Its function means it violates Ohm's law. Let me show you what I mean. We can take a component, in this case a resistor, and plot a graph of voltage against current for it. For resistors, the graph is just a straight line. As the voltage across the resistor increases, so does the current through it. The gradient or slope of this graph gives us the resistance of the resistor. But if we do the same thing for a diode, the graph looks very different. It curves up and doesn't follow a linear pattern at all. Because the graph is curved, the resistance of the diode changes depending on how much voltage is applied. Ohm's law does not work in this situation. So Ohm's law, which appears on your formula sheet as V equals IR, is a clever way to do calculations for resistors and other circuit components. The most notable exception is the diode, for which this law doesn't work. That's all for now. Try out the following exercises to build and test your ability to solve circuit problems with mathematics. Remember, Ohm's law is your friend.